Hello, you are watching a video version of Application Note 42 posted on our website. The link to the original article is in the video description. Application Note 42, NETIO Power Analyzer, explore power consumption charts for electrical appliances with Node-RED. NETIO Application Note 42 shows how to use the NETIO Power Analyzer utility, for Node-RED, to explore the power consumption behavior of electrical appliances. Node-RED is a programming tool for wiring together hardware devices, APIs and online services in new and interesting ways. Node-RED provides a browser-based flow editor and a wide choice of nodes and options. It is built on Node.js, making it ideal to run on low-cost hardware such as the Raspberry Pi as well as in the cloud. In a single screen, the current load and true power factor waveforms are shown. The charts give a clear idea whether or not the energy consumption waveform can be used to monitor the appliance. For example, see how many chewing gums were sold by a vending machine or if a fridge functions correctly. Supported devices: PowerCable REST, NETIO for All, PowerPDU4C. NETIO Power Analyzer is a simple tool for analyzing the energy consumption waveform of any 230 volts appliance. With Application Note 42, anyone can explore the behavior of their refrigerator, coffee machine, vacuum cleaner, and so on. Capabilities of Application Note 42 NETIO Power Analyzer. Works with the PowerCable REST 101x Wi-Fi power socket. The power output can be switched on-off from the user interface. Detailed consumption chart, work, power, true power factor, for the last 60 seconds. Detailed chart of delta values, derivatives of work, power, true power factor, for the last 60 seconds. Measurements stored in a CSV file for later use. 8 detailed charts for the entire duration of the measurement. To draw the charts and create a simple UI, in this Application Note 42 we have chosen Node-RED, which can run on almost any platform. Besides the main screen, additional 6 detailed charts are available in the top left menu. Structure of this Application Note 42. Chapter 1. NETIO Power Analyzer Dashboard Example. Chapter 2. Starting NETIO Power Analyzer for the first time. Chapter 3. How to control NETIO Power Analyzer. Chapter 4. Measurement examples with real appliances. Chapter 5. Modifying NETIO Power Analyzer to work with NETIO devices other than NETIO PowerCable REST. Chapter 1, NETIO Power Analyzer Dashboard Example. This is the NETIO Power Analyzer dashboard. The dashboard consists of 6 parts. 1. True power factor, current and load chart showing the last 60 seconds. 2. Chart with delta true power factor, delta current and delta load for the last 60 seconds. 3. Indicators of the immediate true power factor, current and load values. 4. Controls to start and stop the measurement, with indication of time elapsed in total consumption. 5. Immediate values of all measured parameters. 6. NETIO output socket control with the state indicator. More charts are available in the dashboard menu. The Application Note 42 dashboard includes 8 additional charts. Each chart shows the measured values for the last 60 minutes, so that you can look back at what has been happening. A large chart with true power factor, current and load values for the last 60 minutes. Chapter 2, Starting NETIO Power Analyzer, Node-RED Flow, for the first time. When launching the NETIO Power Analyzer for the first time, it is necessary to configure the JSON API protocol in your NETIO Smart Socket device, import the NETIO Power Analyzer flow and configure the HTTP request nodes. In the M2M API protocols, JSON API section of the web interface, enable JSON API. Set the username and password for read-write access. Read-write credentials allow both reading and writing. The same read-write credentials can be used in both types of HTTP request nodes, POST and GET. Click Save Changes. After saving the changes, the device restarts, about 1 minute. The Node-RED configuration is specified in a JSON structure and can be pasted via the clipboard. You can download it on our website. The link is in the description. Importing the Application Note 42 flow to Node-RED. In Menu, select Import then Clipboard. Copy the text to the indicated field and click Import. Installing missing nodes. The nodes are loaded into the selected flow. It is possible that an error message is displayed with a list of nodes that need to be imported but are not installed in Node-RED yet. In this case, the missing nodes need to be installed. If there are any nodes missing, Select Manage Palette in the menu, click Install and find the missing nodes. For a detailed description of how to install missing nodes and import the flow, see Application Note 29, Node RED example of URL API communication with NETIO 4X. NETIO Power Analyzer Flow. If everything works as expected, the flow should be imported. Any missing nodes installed in the flow should look like this. Now it is necessary to configure all 3 HTTP request nodes. In each HTTP request node, insert the address of your NETIO smart device and the read-write access credentials, if set. Chapter 3. Using the Application Note 42 NETIO Power Analyzer. NETIO Power Analyzer is a unique tool that lets you observe subtle changes in true power factor, load, voltage or current. You can control the output and watch changes in the monitored parameters in real time, and also obtain a log file with all the measurements for later analysis. To create a log file in NETIO Power Analyzer with the measured values and record new measurements, enter the path for the log file and the log file name, ideally before starting the measurement. If you forget to enter the path, it can be entered while measuring, however, values will be only logged from that moment on. If you do not need a log file, NETIO Power Analyzer works fine without it. The log file is an optional feature. NETIO Power Analyzer controls. The NETIO Power Analyzer is controlled with 3 elements. Start button, Stop button, Toggle Output State button. The Start button starts the cycle of downloading measured data from your NETIO smart device using the HTTP request node, HTTP GET, once per second as well as displaying the data in the dashboard. If the log file path and file name are filled in, the measured data are also written to the log file once per second. When the Start button is pressed, existing measurements and charts are cleared and a new measurement session is started. The Stop button stops the measurement session and the downloading of data from your NETIO smart device. The Stop button does not clear data or charts, the recorded measurements are still shown. Toggle Output State. The button uses the HTTP request node, HTTP post, to send a command to your NETIO Smart Sockets device to toggle its output. Chapter 4, Measurement Examples with Real Appliances. Coffee machine. How much energy is needed to make a cup of coffee? NETIO Power Analyzer makes it easy to find out. The coffee machine in our NETIO office uses about 8 watt-hours of electricity, corresponds to about 0.16 euro cent per cup of coffee. Consumption chart for the making of a cup of coffee. At first, the coffee machine preheats. Then it starts making the cup of coffee. The chart shows the changes in current and voltage. First part of the graph is preheating and the second part of the graph is making coffee. Fridge. Fridge consumption in the course of 1 hour. As shown in the picture, the fridge consumed about 24.4 watt-hours during the hour. 24.4 watt-hours per hour equals about 220 kilowatt-hours per year, and assuming 20 euro cents for a 1 kilowatt-hour, costs about 43 euros per year. Thanks to NETIO Power Analyzer, you may discover that your old fridge consumes much more electricity than it should. Maybe it is faulty, maybe it is just energy inefficient. And this applies to all electrical appliances. This chart shows that the fridge door was opened 3 times. This led to a rise in temperature, and the compressor started cooling. First part of the graph, compressor is on. Second part of the graph, opened and closed fridge door. Third part, opened and closed fridge door. Fourth part, opened and closed fridge door. Fifth part, compressor started. Sixth part, compressor is on. Microwave oven. What does the power consumption look like when heating up a dish? How much does it cost to heat up the dish? Let us see. During the minute and a half, the microwave consumed 24 watt-hours. At a rate of 20 euro cents for a 1 kilowatt-hour, this comes to about 0.5 euro cent. Chart detail. First part of the graph, microwave started heating. Second part, heating in progress. Third part, microwave stopped heating. Laptop computer. How much energy does your laptop really consume? And what happens when charging the laptop? During an hour of use, the laptop consumes approximately 31 watt-hours. That is 277 kilowatt-hours per year, corresponding to about 55 euros. As seen in the chart, the true power factor of the power adapter fluctuates quite a bit. Laptop with a discharged battery. When the battery is low, The charts show that the current and load are almost twice as high during the first 10 minutes, while the battery charge remains under the critical level of 20%. It is interesting to see that true power factor is more stable and less fluctuating during that time. Chapter 5, Modifying NETIO Power Analyzer to work with NETIO devices, other than NETIO PowerCable REST. NETIO Power Analyzer is designed to be very simple to use, even if you use a device other than the NETIO PowerCable REST. NETIO Power Analyzer will work with other NETIO smart socket devices, as long as they are capable of measuring electrical parameters. All that is necessary to change manually is the number of the output to control and monitor, if it is different from one. Changing the measured output. The output to measure needs to be changed at two places. Function block, load values. The number of the output needs to be changed everywhere in the load values function node. Outputs are numbered starting from 0 here. Therefore, the first output has the number 0 and the fourth output has the number 3. Button node, toggle output state. Here, the ID of the output needs to be changed. For example, to control the output number 2, the ID value would be 2. FAQ. Is it possible to use an IP address different from the pre-filled one? Yes, use the IP address of your own device. The IP address can be set in the HTTP request nodes. It has to be changed in all three of them. Is it possible to use a device other than NETIO PowerCable REST? Yes, NETIO Application Note 42 Power Analyzer is designed to work with any NETIO device that provides electrical measurements and supports the JSON API protocol. Without further configuration changes, the example will always work with the output number 1. Where can I find instructions to install Node-RED? For detailed instructions on how to install Node-RED, see Application Note 29, Node-RED example of URL API communication with NETIO 4x. Is it possible to test the NETIO Power Analyzer with the NETIO Online Demo? Yes, NETIO Power Analyzer can be tested with NETIO Online Demo devices. To access the NETIO Online Demos, log in as demo at the following sites. The CSV log file was not created. What is wrong? The file path is probably incorrect. The path and file name should look similar to this, c:/users/john/desktop/log.csv. Where can I find instructions on how to install missing nodes? For a detailed description on how to install missing nodes in an imported flow, see Application Note 29, Node-RED example of URL API communication with NETIO 4x. Is it possible to plot a different time period in the charts than the default? Yes, the displayed time period can be configured in each chart node. In the debug section of Node-RED, the following message appears: error, timed out. Most likely, the IP address in HTTP request nodes is incorrect. In the debug section of Node-RED, the following message appears: result, error, code, 401, message, unauthorized. The login credentials are incorrect. I have changed the flow in Node-RED, but the changes are not reflected in the dashboard. To save and display all changes in a flow, it is necessary to click Deploy in the top right corner in Node-RED. Thank you for watching. The link to the original article is in the video description.